today is going to be one of those lessons where we do the always, sometimes, or never. Give me a glow on if you remember that. Okay, cool. And so I know I've said this to you before, and I just want to make it clear that the reason why, so when I was in 5th grade, the reason why I hated these lessons, do anybody remember why? Does anybody remember why I didn't like these lessons? Anybody remember why? Cameron, do you remember?
I think you said because sometimes it was challenging and it was hard to do.
Right. So not only were they challenging, but they also sometimes made me feel like I wasn't the smartest person in the room. Right? Like none of us really like that feeling. I mean, like who does? Especially like because all of us are overachievers, all of us are heavy hitters in the room. So like when we're thinking about that, the reason why I didn't like it is because like I knew how to add, subtract, multiply, and divide. Right? I knew that. But if I didn't understand the concept, if I didn't understand the idea that the teacher was telling me, or the idea that the teacher was teaching, then that's when it became a little struggle. Today what we're going to be doing is investigating one of our superpowers, investigating that concept or the idea of division. Concept or idea of division. 2 minutes on the clock, go. How do you know? Don't tell me.
Sometimes because not all fractions are equal to 1, because if you do 3 over 1, that equals 3. And then like 2 over 2, that equals 1. 4 over 4 equals 1. 5 over 4. I meant 5 over 5 equals 1.
Now y'all do it. So that would be simple, and then we have to convert that into a mixed number.
First question is your answer always, sometimes, or never? Don't yell at that. Use your whiteboard. You have 4 seconds to write that answer on the whiteboard. 4, 3, 2, 1, 0. And I say boards up. 1, 2, 3. Boards up. Cool. So I see 100% of us agree, but I don't know if we agree on the right thing. So I just need to know why, what our answer is and why. And so it's really important for us to understand that if you're telling me why, you're telling anybody else why, you're going to be using those examples or counterexamples that you have to be able to answer that question. Let's hear from Asha.
I agree with the class because I put sometimes like 1/8 on 1/8, so 1 and 8/10 because 1 whole is 1, and if you put 8/10 on the side of 1 whole, it's going to be greater than 1 whole. And then my counter example was 8/10 because 8/10 is less than 1 whole.
Okay. Can somebody restate to me what they just heard Asha say? In their own words. What did you hear Asha say? Let's hear from Xavier.
Asha said, like a whole number, like it can, not all fractions are equal to 1, because if, like she said, 8/10 is just a regular fraction, and the numerator is less than the denominator, and the denominator is the whole number.
So it sounded like what Asha said, and that's really close to here, but I was going to clear something up. So Asha gave us a mixed number. Asha's mixed number was 1 and 1/8. And so it looks like this, 1 and 1/8, for some people that may need to see it. 1 and 1/8 is what we have. Even though this fraction is not the same as 1 whole, it is greater than 1 whole. Is there anybody that showed us an example to prove that fractions are sometimes equal to 1 whole? What example would you give to prove that? Sit there, what would you think?
I picked 10 over 10 to prove that some examples is equal to 1.
Right, and so if Sadeo just gave us a fraction that's equal to 1 whole, and that's an example of a fraction equal to 1 whole, who can give me another one that proves this statement to be true sometimes? Yes, Xavier, you got one?
Yes. So I put 5 over 5. That can be equal.
Yep.
It can be the same as.
They can be equal, exactly right. And I just need one more counterexample. One more counterexample to let me know that fractions are not always equal to 1 whole. What What do you think, Jakara? Well, that shows me that that's an example that proves that statement. I'm looking for a counter example. Jakara's got it. Hands up. Yes, ma'am. 3 over 4 work exactly right. Cool. Let's move on to our next problem. 2 minutes on the clock. At the end of the clock, make sure your answer's written on the board. Go.
Because, like, if you do 25 times 1, you'll equal 25. So it's like the same opposite. Because, like, division and multiplication is like the same operation but different. So we did 25 divided by 1 equals 25. Because if you do the opposite, 25 times 1 equals 25. And then we did 5 times divided by 1 equals 5. If you do 5 times 1 equals 5.
To have us have a conversation about this. Because the goal with this, and I didn't know this when I was in 5th grade, but the goal with this is for us to understand a bigger idea. And so with this one, today we're trying to get to a big idea, and we're going to try to figure out if we can get that together through the questions that I ask you. And so the first thing I want us to look at is problem number 3. Cam, go ahead and read it for us.
When you divide 10 by a number less than 1, your quotient is smaller than 10.
Okay, so I know some of us are thinking like, the number less than what? Give me a hand in the air and give me a number that's less than 1. What number is less than 1, Lakeisha?
0.
0. Cool. So if I do 10 divided by 0 on 3, what's my answer? 1, 2, 3.
0!
Yep. Yes, our quotients are greater than our dividend, so that's a step in the right direction. We notice that, but when are our quotients greater than our dividend? When is this number greater than this number? When is our answer greater than our dividend? When is our answer greater than our dividend? Sit there.
When the product's a fraction.
When our product is a fraction, I like that, but you're missing, I'm sorry, but your word is a little off. Products are with multiplication problems.
Oh.
When our
Divisor.
Exactly right. So anytime when we divide by a fraction, anytime we divide a whole number by a fraction, tell me, can somebody finish that sentence? Keanu Bam, what you got?
When you divide a whole number into a fraction.
By a fraction.
Your quotient is going to be larger than the dividend.
Yes. Can I have an example?
8 divided by 110 equals 80.
Can I have another example from somebody in the room?